So today we are going to discuss the third problem of AtCoder regular contest 132, which is almost sorted. Now we are given a sequence of integers a, which is a obviously permutation of integers, but some of the elements are missing, which are like replaced by -1. So we have to like replace the elements by something, and some values which are less than equals to 1 to n, which are between 1 to n, and there are two conditions given here, that ai should be equals to pi. So I mean, if ai is not equals to -1, we can't change the item. If it is -1, then what we can do, we can just change it, but the absolute difference between pi minus I less than equals to d. So that is the question. This question is a bit tougher than the previous two. So what we have to do here is that, let us take this, the first test case first. 4 2 3 minus 1 1 minus 1. So we can put 2 here and 4 here, or 2 here 4 here, or 4 here 2 here. So these two answers are possible. Mm, so the answer is 4. So what I thought about reading after reading the question is that if we just store the all the elements which can sit at this position, if we just store all the elements which we can sit at this position, and we will put one element and then shift the window to the right. Okay, so this element will get removed and extra this element will get placed here. Okay, so the number of elements that can sit here will be 2 into x plus 1, right? Let me understand. Let me explain this part first. So if the current element is I, then I minus d to I plus, sorry, this is 2 into d plus 1. Actually I have written x in my implementation, so I am just explaining it with x. So you can say d is equal to x, same thing. So I minus d to I plus d, there are a total of 2 into d plus 1 element. So we can just shift one position from here, left shift this array, and add one element from this, like for at the, if d equals to 2, and we can like just place mm, we can just place d equals to 2 and I equals to 2, I equals to 3, let's say. So we can just place 1 2 3 4 5 in this position. Now if we move I to 4, okay, now if I becomes 4, then what we can place here, we can place here 2 3 4 5 6. So it the last element from here will get replaced by another element. Okay, so after reading the question, I thought about, as the number of is d equals to 5, the maximum value of d equals to 5. So why should not we like maintain a mask, like bit mask of length the 2 into d plus 1? The maximum value of this will be 2 to the power 11, which is very less, because 2 to this will be 2 to the 2048 into n is like 500. So it is like possible. Okay, so we will just store in a mask that the number of elements stored, like already used, we will like place 1 if the element we have already used the element, and 0 if we have not used the element. Okay, I think you have understood that. Like if the if the third position, if we want to place one, like if our bit string is like that 1 0, if d equals to 2, d equals to 2, and our bit string is like that 1 0 1 1 0. So what values we can place is that we can place 2 or 5. Okay, if the bit string is 0 0 1 0 1, so we can place here what 1 2 and 4. Okay, so so now if we are going from third index to fourth index, so how our mask will change? Okay, if we go from third index to fourth index, how will our mask change? If we right shift our mask by 1, so what will happen? Let's say this is our mask. Okay, 1 0 1 1 0. So 1 0 1 1 0, and if we right shift our mask, it will become sorry, left shift our mask, it will become 1 0 1 1 0 0. Then if we just subtract the most significant bit, like most significant bit, I mean the 2 into x plus 1 bit, 2d plus 1 bit from this, like if we just eliminate 2 into 2d plus 1, then our answer will, our new mask will get 0 1 1 0 0. So this will be mask for fourth. Okay, I hope you have understood that. So let me go to my code, and I will explain my code line by line to you. Okay. So let me expand this. Okay. So we have taken one dp of this is index and this is our mask, and this is k, which I have stored 2 into d plus 1. Here I have used x instead of d. Okay, so I hope you have understood that. So and a is our array. So we have taken input n and x. I have stored k as 2 into x plus 1, and I have like set all the values of dp to -1. Now I have used one based indexing here because it is creating some problems to me if I have used zero based indexing earlier. So now go to the our recursion code. So if I equals to n plus 1, then one answer is possible, so I will just return 1. Okay, now if dp I mask is already stored, then we will just return this like this thing, like it is memorization, nothing else. Now I am storing dp I mask like 0, like it is just initializing a reference variable answer such that we don't have to use the dp I must thing again and again. Now we will just iterate from I minus x to I plus x plus 1. So you have to consider that I minus x could be 0 or negative, or I plus x plus 1 could be greater than n. So we have to take these things. Okay, so if ai not equals to 1 and ai not equals to if ai, let's say ai equals to 5, so we are traversing from like what, like if I is 3 and ai is 5. Okay, I is 3 and ai is 5, so we'll traverse from 1 to 3 4 5. So for this cases 1 2 and 4 5 will not go to the implementation part, because only for only 3 will take the part. Okay, for -1 we'll take for all 5, but if ai is not equals to -1, we have to check for this 3 only. Okay, I hope you have understood that. So now if we have to check if the current value is set or not. Now for setting it, like so there are two in 2d plus 1 length mask. So let's say this is 5-bit mask, like 1 0 1 1 0 5-bit mask. So the most significant bit will be our I minus x bit, I minus x, and second significant bit will be I minus x plus 1, like that. So by calculating you can find out that this is 2 to the power 2d, I think will be I minus x. By this thing you can easily find out what will be the value. I think the value will be x plus I minus j, sorry. So the value will be d plus I minus j. Okay, let me take one example, like if let me delete these things first. If let's say j equals to I minus x, then what will be the value of this thing? The value of this thing will be d plus I minus I plus x, so which will be equals to d plus x, d plus d, I think x equals to d, so d plus d equals to 2d. So it is 2d. This thing I think I have to delete this. This will be d, this is d, so this is 2d. So for this index the power will be 2d. Okay, for this index the power will be 2d minus 1, for this index the power will be 2d minus 2. So for this index the power is 2d, like I think this is 4, for this index this is 2, this is 2 3, for this is 1, this is 0. I think you have understood it, how we are getting this d plus I minus j part. So d plus x plus I minus j is equals to 0, equal to 0. That means we have not used this part. So our new mask will be this thing I have explained to you, is that we will just use it and then left shift this. And now if I greater than x, then we are subtracting the part. I have explained it here, that we will have to like delete this part, 2 to the power x, 2 to the power k. If new mass less than 0 x is 0, I think this line is not needed. Else answer will be answer plus, I think this is quite trivial. I hope you have understood my solution.